Okay, so I have been working on a circuit here. I'll get my notebook. I've been spending a lot of time in the garage working on an old TV, recording a lot of stuff for that. But it's time that I have a proper power supply. So I'm going to have this scanned up and links and everything for where I found the circuit. Somebody at Elect Circuit, their name is right here. I'm not even going to bother trying to pronounce that, but like I said, it will all be scanned and linked and everything. This is my implementation on the board here, and basically I had to substitute a couple different things. So I don't have 12K capacitors or resistors, so I'm going to be using one 10K and one 2K in series. That'll give me the 12K that I need. And I don't have any 470 mic 50 volt. But I do have a lot of 120 mic 50 volt, and in parallel, capacitors are the equal capacitance of all of their individual capacitances added. So if I do 4 times 120, I'm getting 480. So I'm getting 10 microfarad over what I should have. So I'll be using 4 of these in parallel. As you can see here, I had to jump them over to the side because the way my leads come out, I want to have a little room in the corner here for them to just kind of run out easily. If I lined all these capacitors up, it would take up all the room, and I would have to jump wires and stuff across to get one equal output of 2 leads. So jumped them over a little bit, gave me a little bit of room to just run around the capacitor with the leads that I have here. These are going to be my leads. This is just an alligator clip that I cut in half and took a red cover off of one of the other alligator clips and threw it on here. So now I have 2 leads, one black, one red. That'll be my positive and negative. And for weeks, I have had a little heat sink laying around here, and it's totally missing. I have been meaning to do this for weeks, probably months at this point, and now that heat sink is nowhere to be found. So I was going to use this one, and it was just too big and had a lot of holes in it. It just looked too ugly. Then I made something out of a Coke can, and that probably would have worked, but it's ugly. So I went and I had actually cut a piece off of a heatsink like this a long time ago, and I have that here. So this is a few rows of a heatsink just like that, and I've basically gone to the side of a grinder wheel, held this with some pliers, and ground off the middle. There was a big metal ridge where the chip mounted. I ground that down and held this against the flat side of the wheel in order to get it relatively flat, and then I used a big piece of plate that I got off of the scanner section of an old laser printer, and I set the glass down on the concrete and got a piece of sandpaper, relatively rough grit sandpaper, and just did one of these, flipped it around, did some more, and basically lapped the bottom of this thing. So I've got it flat enough, at least for this one chip that I need. So I drilled a small hole and went ahead and ran this 632 all the way through it, and this 632 will thread out of here, and with that I'll be able to go through my chip and go into the heat sink like so. Tightening up on there. So something like that, and I'll tighten that down when I'm ready. But that'll be my my heat sink for this little LM317. So the parts on this circuit, the main, like I just said, the main integrated circuit for this whole power supply is the LM317. I have plenty of LM317Ts, and I bought those relatively recently, but I'm not going to use those because I didn't source those. I bought them. So this one I actually sourced out of a very small 12 to variable voltage supply. So this will plug in the cigarette lighter, has a little LM317 here, and puts out whatever voltage you select here. So as you can see, these resistors are ran through this 4 or 5 pole switch, and as you select, it goes to different resistances, basically varying the LM317. So this did 12 volts, 9 volts, 6 volts, 3 volts, something like that. So Yeah, I hate these because there's nothing safe about them. It's basically plug and play, nothing but resistors and an integrated circuit and a very, very bad heatsink. So as I was playing with this, I actually broke it. As you can see here, the leads broke some board off with it. So I'm going to pull the switches and stuff off of here. The circuit board will be trash. So I sourced this out of that, and I'll be using this as the main integrated circuit for this power supply. So I go back here. So in the implementation, I am going to be using a base input voltage of 32 volts. I think the LM317 is up to 37. So the way you think about this, you can't take any more voltage out than you're putting in. So you can't put in a big 12 volt power supply and expect to get 1 to 37 volts out of the integrated circuit. That's not how it works. You have to put in voltage in order to get that voltage out. It's kind of like a operational amplifier. People assume that they're getting voltage out of nothing, and that's not the way it works. It works off biasing and regulating. So it biases inputs and outputs and regulates voltage that's inputted from somewhere. So if you're putting in 9 volts, you can only get out 9 volts. You can't put in 9 volts and get out 10 volts, or put in 5 volts and get out 9 volts. It's not possible. So the 32 volts that I'm going to be sourcing is a little tiny printer power supply. Believe it or not, this is the printer, this power supply from one of the printers that I took apart, but I didn't film it. So I have footage from a printer, but it's not the one that this supply came from. This came from a small HP printer. And I have several of these supplies, but the reason I use this one is because all it puts out is 32 volts. So most of these will put out 16 volts at a few milliamps and 32 volts at a few milliamps. This puts out nothing but 32 volts. So it makes it real clean having 2 wires coming right out the back of this thing. And not only that, it takes your typical TV or PlayStation power plug right in the back there. So I'm going to be having my 32 volts coming out of this small supply. Totally protected. You can short it out, no problem. It's got a little indicator light on there. I want to try and stand this off, and it's going to have the B10K resistor somewhere about like that. It's going to have the LM317 somewhere about like that, and the input is going to be, where do I have the input? Right down here at this capacitor, somewhere about right here. And then I'm going to have my 2 leads that come out of each side of the capacitor somewhere about right there, out of that capacitor chain right there at the corner. So this should be a good first power supply. I've got a nice strong 0.6 amp coming 32 volts out of here. So this chip will do up to 1 amp. The LM317T will do up to 1.5 amps, but I'm well within the safe range. As long as this cools the chip properly, I should be able to run 32 volts in and out and take the full 625 milliamps, no problem. So I'm gonna go ahead and get some things situated, and then we'll get started. Okay, I was gonna start writing down the rails and kind of counting them and stuff. I'm not gonna do that. I am gonna walk through this because here's the circuit up here and here's my implementation. I've walked through this a bunch of times in the making of this, but I'm going to go ahead and walk through it again and kind of look at all the connections, make sure everything's right. So from the input, right across the input, we have our 0.1 mic. That's going to be our little ceramic guy right there. The negative from that goes up all the way across those capacitors. So I'm actually going oh, okay. I got that mixed up. I saw this negative sign here. Putting that positive and negative right there, I knew that was going to trip me up when I did it, so I'm not going to worry about that. I'm not going to put any polarities on these capacitors because all that does is mess me up. Actually, I'll leave that one there because I know that's electrolytic. Okay. So I have the input that goes to the 0.1 ceramic mic, and then the positive goes over to the input of the chip right there. It also goes to the plate of a diode, and that diode goes around back to the output. That's correct. And from there we go to 1 resistor down through the 2 other resistors straight to ground. So we go through the resistor, right here through the resistor, down through the other 2 resistors into ground. So we've got that good. And in between those 2 resistors, we break off and go to the adjustment. So as you can see right here, we go through 1 resistor, and between these 2 resistors, we go to the adjustment. And also from that jump between these 2 resistors, we go back out and go down to the variable 10K. So from the adjustment, we have our 1 and then 2 resistors here. So between these 2, we're going to have to break off and go to the B10K right here. That's going to our B10K resistor. And on top of that, also between the 2 resistors, we're going to the positive of the 10 microfarad capacitor right here. So between the 2, we are going to the positive of that 10 microfarad capacitor and then straight to ground. That looks good. And when we jump out here to that capacitor, we're also going to the grid of a diode. So right here, we're going to the grid of the diode. That's from this capacitor. We're looking right here now. Going to the grid of a diode, and then the plate of the diode is going straight to the positive rail on the capacitor bank here. And indeed, that plate does go straight to the capacitor bank right there. So I know my circuit is right all the way around. So I'm just going to go ahead and start kind of soldering these things in, and then we'll worry about getting the legs bent over, start running rails across, and see what I have to bend out and everything in that way. So I'm going to pull these components out. I'll go ahead and start with my big capacitor bank here. It looks like our sponge is nice and soaked. Okay, I'll go ahead and prop this up over here somewhere. Paperweight, there we go. Okay, get my helping hand. I'm going to bend these legs out a little bit just to keep them, help me keep the capacitors in the board. Make sure they're all looking good. Make sure they're all looking straight, and then I'll flip this thing right over. I'll put it in the helping hand, and we'll start soldering. I should have warmed the soldering iron up here, but I didn't. So let's get our flux out, and solder. Turn my baby on. Best soldering iron I've ever bought. Only soldering iron I've ever bought. All my other soldering irons have been hand-me-downs. Got it set to 800. Is that where I normally have it? Yeah, I think I normally have it on 700, so that's where I'm going to have it today. Let this sucker warm up. I have quite recently had that itch to solder something, so I'm glad I'm doing it on something that I really need. That EEPROM programmer is cool, but it's totally unnecessary. So there we go. Got it fluxed and ready to go. I'm going to go ahead and solder these in. There we go. Go ahead and clean the soldering iron off. I'm going to turn it down for a minute. Go ahead and tin it just to protect it. Alright. Smoky, smoky. Okay, what do I want to put in now? Let's see. how about I put in the variable cap? I think I got this knob already aligned. Yeah. Okay. Go ahead and put this variable cap in. It looks like we skip 5 holes and 2 holes back. So 1, 2, 3, 4, 5, and then 2 holes back. 1, 2, 3, 4, 5. Okay. There we go. There we go. Bend a couple of the legs over a little bit just to keep that. It's a heavy component, so it's going to want to flop around, but do I have this right? I don't want to mess around. I am kind of running into my electrolytic there, but that should be okay. Do I have room to jump over one? Yeah, I do. I do. Let's see. I jumped over 2 from the leg of the capacitor. 1, 2. And then jumped 1, 2. Up. So 1, 2, 1, 2. Yeah, that's where I have it. Okay, well, that's where I'm going to have it then. I'm going to leave it there. I don't like changing things in the middle of everything, because that makes me question the whole circuit in general. Go ahead and turn this baby back up. What else do I need? I think I'm going to go with, let's do that far capacitor. That's going to be the 10 microfarad, 50 volt here. And it looks like we're going off the positive rail, if I'm not mistaken. No, that's the negative rail. Okay, here we go again. Let's follow this. So I got the negative here that goes up around the whole capacitor bank, around the side. Okay, the negative is far against the end of the board. So I'm going to take my negative upward, and I go jump 2 holes to the right and align it with my pot. There we go. Okay, I can't get that hole perfect yet, but if I run into a problem where I need to, I'll go ahead and fix it. Okay, I got my 10 mic cap in there. I'm going to go ahead and start working around. So, got the 10 cap. I'm going to go ahead and let's throw the diode right here and there. Looks like the plate's going. I have it set this way on paper. The plate's going that way, and the plate is lined up in between the legs and goes 2 holes back from the variable capacitor. So I'll line the plate up and go 2 holes, 1, 2, 2 holes back. Okay, let's check that one more time. Jump 2 holes and lined up. Jump 2 holes and lined up. Okay. Looking good. Now let's keep going around the corner here. I'm going to need both of my series resistors. Now again, I needed a 12K resistor. I don't have it, so I'm going to have to go ahead and use a 10K and a 2K. I don't care which is first, honestly. There's one. There's two, as you can see here. And I just had these bent differently, so I'm going to have these two kind of doing the rain loop kind of thing, and then this one will just be the square bent. The only reason I did that is so I could tell while they were sitting here in a pile. So I'm going to bend these legs out a little bit. Okay. Pulling them out and bending the legs and then letting them fall down seems to be a good idea because it kind of lets them settle straight. They tend to end up really looking really good that way. There we go. I don't want to get my tip too dirty. That's what she said. Well, that's what he said. Well, nowadays I guess you don't know. Okay, reach around the monkey. There we go. I'm going to do one terminal on the other resistor. There we go. Looked like it wasn't going to stay for a second. Good. Okay, let's see how that turned out, those two resistors. Ah, that looks good. Focus, there we go. Looking good so far. This will be the front. And I'll have a trim here, and my leads will come out this front corner right around the capacitor, and the input will be right in the back here. And that'll sit right on top of my little 32 volt printer power supply. Okay, so moving right along here, I'm going to go ahead and put in my last resistor, and that's going to align with that side of the diode with that leg and jump 2 holes down this way. So align with that leg and jump 2 holes down this way. There we go. I don't want it to stand off too much. It doesn't need to. Okay. Coming right along. Got my last resistor in there. And that's lined up with that leg. So this is looking good. Coming right along. Okay, last diode here. Looks like the plate's going that way. And I've lined up my left leg and jumped 1 hole from the resistor. There we go. There we go. Last diode's in. Looking good. It's a little cattywampus, but it looks good. It stood off a little bit. Doesn't look burnt. That sounds good. Okay, let's get the capacitor here. This is bidirectional ceramic capacitor, and this says it's right up against the edge of the board, but I'm actually going to take it 1 hole up. Because if I do that, that gives me some holes to put the wires through from my 32 volt printer power supply. So go ahead and put that in there. Bend the legs. Make sure the standoff looks good. All right. Make sure I clean the tip real good. So all I have left is the integrated circuit here. I'm going to go ahead and see if I can actually clean this off here. I shouldn't have turned my soldering iron off yet. That's okay. Alright, get this tinned up a little bit. And I should be able to just, I'll take a piece of solder wick just to help me kind of grab it off of here. I should just be able to walk that piece of board right off the end. We'll tin it, and then I'll just go ahead and tin up these leads. Yeah, that IC does get a little hot, so I don't want to burn this thing up. Like I said, I want to use it because I sourced it out of something that was broken. Okay, so the IC is going to be lined up and jump 2 holes from this resistor leg. So right here, I'm going to solder that in place, and then we'll start worrying about the rails. It's coming along pretty good. Okay, I went and got some coffee, and I'm coming back to it. So I think I should wait for throwing the IC in. I think I should go ahead and use as many of the legs as I can to bend as many of the rails as I can. So I'm going to bring my circuit diagram in here, and we'll just go ahead and start doing this. So it looks like we need to start jumping these capacitors over. So it's actually upside down flipped. Not really a good way to do this. On the inside. There we go. Now they're all uniform. 1, 2, 3, 4. So I'm gonna wait to solder that. I'm gonna go ahead and see what else I can do. So it looks like one side. Do I have this right? Yeah, it has to jump over that capacitor. Okay. So this lead can actually be cut, and I'm gonna need a rail. Let's see, let me think about this. The way I wrote this down, I jumped over the capacitor. Okay, I got an idea. I'll go through the top with the rail in between the capacitors. Let me go ahead and erase this. Okay. I think the cleanest way for me to do this is to go exactly 45 between these capacitors with the rail from the top, tie it into the negative here, and then try and bend the leg of this capacitor over. I think that's what I'm going to do. So let me go ahead and get some wire together. Let's see. 4. So I want to go 1, 2, 3, 4, and then I'm going to go diagonal 4. So I'm going to try and straighten this out as much as I can, and then I'm going to take the square into these pliers and get a good bend on one end. Then I'm going to measure how far I need and put my nail there and just give it a kick up, and now I know where to bend it back down. So I'll try and grab it with the pliers. It may need to be adjusted a little bit more, but we'll figure that out. There we go. Okay, so I'm going to go ahead and cut that. give it something to solder to. I'll go ahead and place this. Let's see, I'll use tweezers. There we go. Okay, I got it dropped in there. I'm going to hold it down and try and kick the legs over a little bit just so it stays when I'm trying to solder it. There we go. There we go. So I'll just put some solder in the corner, try not to get it to stick to that leg. That'll be fine. A nice 90, little rail between the caps. There we go. Now I don't have to worry about it. So actually I am going to go ahead and get the soldering iron started. I'm going to go ahead and solder that in. Oh, I didn't have my flux open again. There we go. Got it nice and tinned. I'm going to go ahead and get this far leg first. There we go. I'm going to get the far side of this leg. And try and get right here in the middle. Bend that a little bit. Get a little flux on there. Help things separate. Solder. Alright. Go ahead and clean the tip. Turn the soldering iron down. And let's see what other bends I can make. Oh, I didn't mark that. There we go. So now I got the there we go. And then that went straight over here and there. Okay, that'll work. Now the positive side of that capacitor going straight up to that diode. Is that a diode? Yeah. Oops. I shouldn't have bent it like that. Now it's ugly. Now where does that other side go from the diode? That jumps 3 holes and goes right back down. So I'm going to fold this down. It jumps 3 holes. Okay, there we go. That jumps 3 holes. 1, 2, 3. No, it goes 1, 2, 3, and then into there. So actually, it should have just jumped 2 holes. Do I want to try and bend that out again? Yeah, I think I'm going to. Yeah, nobody saw that. Okay, that'll work. Jump in 2 holes, and then on the 3rd hole, or on the 4th hole technically here, that's where the IC will come in, and that'll go to the input. Let's see, what else can I do? The other side of that diode. The other side of that diode is going to go to the resistor, straight up to the resistor. I can go ahead and cut that. Go, and the resistor will go straight up to the other diode. And that's actually a few lines up, a few holes up. There we go. Go ahead and cut that. Yeah, and that diode leg kicks over, so I don't need to use that leg for anything. Oof. I kind of grabbed the solder mask there with my cutters. That wasn't good. Okay. Up, and then at the diode's going to go straight over to positive on the capacitors. That's easy enough. Make sure I don't cut anything else here. Okay. And that final capacitor leg, can it just be cut? I have cap, diode, resistor. I'm starting to get turned around here. It's starting to confuse me. far side of that resistor is going to go straight up and meet with the other diode. So it's this side that's going to go up to right between the diode and the resistor. Yeah, that's right. That's right. Okay. Reach down here and cut that. Okay. And right here in between those two resistors, those are just going to be tied together. There we go. Okay. The far side of this resistor goes up to the top of this capacitor, all the way up to the very top of the rail. And it's going to go right through there. I'll go ahead and try and get that 90 again. Let's see, I want to make sure that's well away from the capacitor because it's supposed to go to the far end of this capacitor. And I'll bend that over 90 degrees towards the capacitor since it's being tied to that top side. I don't like going diagonal across the board if I don't have to. It just makes the project that much more complicated. There we go. That'll work. Okay, now what's going on here? Yes, and the diode, this is right between the diode and the gang resistors, and that is going to have to go downward, and it's going to jump 2 holes. Let's see, do I have that lined up right? Yeah, it's going to go downward, jump 2 holes. And from there, it's going to jump over to the negative of that capacitor. And the negative from the capacitor is going to go straight up, and the bottom of the capacitor is going to go over to the variable resistor. And that's going to go into the variable resistor. Oops, right here. And jump over through that. And cut that leg. And I'll cut this leg. I'll leave a little bit more of that leg than I wanted to. I only wanted to jump 1 hole because that's all I needed, but if I put it all the way across, it'll help the solder flow. Okay, now what do I have? I have 1 more lead here between the capacitors and the resistors, so let's see. It's not complex, it's just what I'm working with. I don't do this for a living, so. And having the resistors and the capacitors ganged up like this, it makes it a little bit more complicated because you end up with more connections than you need. That's what I'm working with. I'm ending up with legs that could probably just be cut right where they're at, but I want to make sure. Yeah, I need to jump 1 hole. So I think I'm just going to go ahead and bend this right about like that. I'm going to take it with my tweezers and see if I can drop it in the hole that I need. There we go. That'll stay just like that when I solder it together. Okay, it looks like I've got it right so far. So the diode, I think, can just be bent over 1 hole and snipped right there. So I'll just make sure to clip it real close. There we go. Trying to make it nice and pretty. So that has to go straight to the lead, to the left. So I don't need that leg. I'll just kick it over to the right, or the left. And I'll just go ahead and snip it at the far hole. That way I can put the lead in anywhere I want right here and solder it up, and it should work fine. And then this far side, oh no. Oh wait, no, that's okay. Okay, so I did actually need a little bit of that leg. That's good that I did that. So I have to kick that over one hole, and then I'm going to need a rail going to the far side of this variable resistor. So I'll make sure that's bent down good. I think I'm going to bring the rail down though, because I kicked up, went over, and then up. I should have just went up 2 holes and then over 4 holes. So yeah, that'll go up, and then I'll put one rail here that only has to jump over 1 hole in that case. I think I have that bent out enough. Hang on to that. Nope, I sure don't. I'm gonna go ahead and use another piece. No sense in trying to conserve it. And jump. There we go. Throw that in there, and I can just cut these legs right up top. There we go. Alright, and then that'll jump over and then go to the far side of this variable resistor. Or no, right here. There we go. I'm backwards again. I'm upside down. So it's going to go up 2 holes, over 2 holes, or over 4 holes. Right into this variable resistor. Okay, and what does this side of the capacitor do? I think that's just going to go over 1 hole because that's where my lead's going to come out of. So I'm going to need to jump right outside the capacitor itself, just so I have enough room, because the capacitor is a little wider than a hole itself, so I need to actually go outside to match that lead. Okay, I think that's it. That looks good. Now we can go ahead and get our helping hand here and start soldering. I want to make sure I do this right. It's very easy to just start soldering stuff and start messing up. I just want to make sure for a second that I do have this right. Okay, what's the wiper going to? I'm missing a couple rails here. Let's see if I had that right. Nope. There we go. There we go. Okay. I'll go ahead and cut this. Give me just something to solder to. And I'll go ahead and drop this rail in there. And I'll get this solder. Okay, I'm going to go ahead and turn the soldering iron down, clean it up. Okay, now I think I have one rail to put in here because I actually, the output is going to go to the far end over here by the diode and the resistor. So let's bend out another little piece of wire. Let's see, where did I put it? Okay, right between the resistor and the capacitor, or resistor and the diode. I think I'm done. So now I'm just going to go ahead and look over this thing and make sure all the solders are good, and then make sure I did all solders in the right place, and then I'll worry about putting the leads down and putting the IC in. Okay, camera straight here. There we go. So what we've been doing so far is working on the back side of this, getting all the solders good, making sure they're all complete and how they should be. Everything looks relatively good to me. What am I doing? Oh, I just realized I missed one right here. Let me go ahead and take care of that. That's my diagonal rail going down to the negative of the input. I knew as soon as I started the camera that I had forgot something. But while that heats up, I'm going to go ahead and show you that I have the LM317 here. This is my heatsink that I cut off and filed and loosely, you know, very jury-rigged lapping style. Basically, did a lap job on this this heatsink and drilled a hole, screwed a 632 through it to get threads, and then put the IC through it. And I'm going to put a dot of thermal paste behind it, but I'm not going to do that right this second. I think I have that now. So, like I was getting at, I'm going to go ahead and take my IC, where did I just set it? There we go. And because I flipped the heatsink over, I have a little bit of leg left over, and these three solder points here, that's where that should line up, where I have adjust, output, and input from top down. That's the pin out of the 317. And that'll be nice and flush on there and look nice and pretty. So I'm going to try and hold this straight on here some way and go ahead and get that soldered in and get it jumped to its points, and then worry about getting the leads on there, and then we'll plug this thing in and give it a shot. So it looks pretty lined up right there. I want to see if I can set something heavy on it, or maybe I can just hold it. Alright. Turn that off, clean up the soldering iron. And I'm going to check this with a multimeter and see if I actually do have connection. Go ahead and put it in the helping hands, even though I don't really need it for that. I don't know if you'll be able to hear the beeps, but you should be able to see on the screen here. Excuse me. There we go. We'll check the adjust. We'll check the output and input. And we'll go between the pins, make sure we don't have any continuity. Okay, we got some ohmage like I'd expect, but no continuity. Now all I really need to worry about is getting the leads through the board where I want and tying them in. So I'm going to go ahead and do that. I would like to try and solder the back of this heatsink a little bit just to keep it in place, but I think it's good. I think it's good. Okay. I think I'll put my output leads in first. Got my positive. I'll dip it in some flux, but I'm not going to solder it just yet. I want to get it through the board. So it's going to be facing me like that. And I think I wanted to jump to the positive. Right back there. Okay. Let's bend that over a little bit just so I can keep the lead in there. Now I'm going to go ahead and get the negative. The negative's real easy. The negative will just be right out in front here. I'm going to make sure it's spun real thin so I can get it through the hole and put a little flux on it so that when I solder it, it'll be nice and easy. Okay. Jump right in there. Try and bend it over a little bit. There we go. So now I should be able to throw this in the helping hand. Okay. I'm going to hold them from the bottom while I put these in as well. That way I can get them, make sure they're all coming out straight where I want them to be. This is coming on pretty good. I'm going to be surprised but happy if I just plug this thing in and it works. Okay. Did I get that without shorting anything? I think I did. Okay, now I got my output lead soldered in here. And it is negative and positive, thank goodness. I don't know if this is a good idea, but I'm going to tie them. So I'm probably going to untie that. That looks super ugly. That's alright. I'll leave that there for now. Okay, and the input is just going to be going directly across that ceramic capacitor. Throw it in the hand for a second. Bring my power supply over here. And I happen to know, I'm going to double check with the multimeter, but I'm pretty sure the negative is the marked wire. So the negative is the marked wire, and I know my diagonal rail here, that's going to be my negative. That's my negative side. So I'm going to go ahead and put the marked wire in here. Oop, actually I should probably start with some flux. There we go. And actually let me short that out. There we go. Go ahead and turn this back on. I'm going to solder that in place and jump it to the capacitor. Okay, I should have variable 32 volts coming out of the end of that power supply there. I don't know how dependent it is on load. So let's see, I'm just gonna wing it. Hopefully nothing catches on fire. If anything's shorted out, you'll see it on the status lamp there. I'll go ahead and grab it with the hand on the far side here, just to make absolutely sure I'm not shorting anything out. Okay, and I'm going to put the meter up here. You're recording, right? Yeah. Okay. Put the meter up here. Go ahead and clip on my output leads. Risking it for the biscuit. I'm going to turn it all the way down. Okay, everything should be good to go. I'm going to go ahead and put it on the 200 volts range, because even if it's 200 volts AC, it's not going to be 200 volts because I have 120. I'm in US, so let's go ahead and give it a shot. Okay. All the way down, 1.2 volts, just like it should be. I don't see anything smoking. I see my status light on. Let's go ahead. We're going to do this together. Ready? First homemade power supply ever. Ready? Oh, holy cow. Oh, holy cow. That's 21 volts. I'm not hot, but I'm not drawing anything either. Oh, holy cow. 30.5 volts? I'll take it, man. I'll take it. So I'm losing 1.5 volts. I'm basically losing my minimum capacity. So 1.2 volts. That's about what I'm missing up at the top end. Look at that, dude. Oh, dang, dude. Dang, dude. Damn, Daniel. I'm excited, dude. Hell yeah! Woo! This is my luck. This is my luck right here. I just got done with this beautiful piece of art. You've seen it work. And I told you about how I lost that heatsink. Look what I found. Right when I finish the project and I'll get done making all new heatsink, putting it together, I find the original heatsink. But that's okay, because the new heatsink I made, I think, works out a lot better. So I'll be using that for something else. But I do have a very unlucky disk drive motor. I want to try and overload it. So let's go ahead and get some leads here. If I can do this. There we go. Okay, so I think I've got the positive there and negative there. Sure. Okay. So I'm going to go ahead and turn this all the way down. I'm going to see if I can get it spinning first on maybe 1 volt, and then we'll crank her on up. Let's see if it'll turn. You know, I got a better way to represent this. I'm going to go ahead and unplug it. I'm going to put a piece of tape on the motor like all the fancy guys do. Okay, give me a second here. I got to find some tape. Okay, that should be a much better representation of how fast it's moving. Go ahead and get the meter on here. We should be down at 1.2 volts. Go ahead and get my motor hooked up. Right off the bat, you should see we're spinning right along. It's funny because it's actually spinning maybe 30 or 40 RPMs faster, but the frame rate of my camera is like perfect. So I'll go ahead and start turning this up here. Go ahead and fly off. 2.5, 3 volts, 5 volts. Let that run for a second, feel my heat sink, make sure my LM317 isn't getting too hot. A little higher. Seven volts. Moving quite a bit of air now. Getting a little warmer on the heat sink. 8.5 volts. A lot of vibration now. Heat sink's about the same, 8.5 volts. 10 volts. Mind you, this is a 5 volt motor, so I'm overclocking it by double its voltage now. Overclock. $11 volts. Now it's really starting to kick. 12 volts. This is a 30 volt power supply. Pulling 12 volts, getting a little heat out of the power supply here. 15 volts. 18 volts. 20 volts. That scared me so bad. Oh man. Oh man. Oh, that was fun. I like this power supply. I'm very happy with it. I've never had so much fun with the disk drive motor in my life. Oh yeah, you can hear the crunchiness in those. I can feel the... Yeah, it looks like that's maybe like a 2-brush motor, and I'm missing 1 brush, because I can make like 1 revolution and it binds up. I can definitely feel the electronic, the magnetic field turning it counterclockwise. How interesting, man. How cool is that? I am so glad I made this power supply. Thanks for watching.